Uh, we have Today we are going to explore mathematics. We will first of all we will select first any random, not random, chapter wise. We will select a chapter. Then our work will be exploring. Our work will be exploring that chapter. So I think we should select what mathematics chapters in class 11 with the notes. This is done. First chapter, I think it is done. Uh, Next is the relation and functions. Let's explore this. It will not take too much time. Just we will see what concept. Uh, if we see questions, then it will take too much time and it will not be useful unless you do practice. Then just concept theoretically you can understand, which is very important to understand concept. But when it comes to questions answers in mathematics, then you will have to practice anyhow. So through word, behind me you can see this is my board. So I will take some classes, uh, which subject would be math, and all questions I will take from a chapter, and all chapters I will be covering. All the questions from all these chapters will be covered through this board. But from this, theoretically, it is not possible. Okay, it is not possible. Yes, just concept we can understand through this device. Here we selected relation and function. This is chapter 2. First chapter is a set. What is a relation? As we know, a meaning of relation among us. So what is a relation? Brother, sister, mother, father. All these are relations. Same here. Something we will realize. Something we will realize a relationship that we know. Relations and functions. First of all, we need to understand uh, what is a Cartesian product shades. What is the Cartesian product of the shades? Then we will be able to understand what is a relation, what is the meaning of a relation. If we are clear about the relation, then we are able to move to understand function. This is how, if you follow like that, then you will not face any challenges. Now, challenges. What do you mean? Challenges. I mean, if you jump randomly, for example, you don't understand a set, you don't understand relation, and you are directly jumping on function, then here you will not be able to understand about the function chapter, because you directly jumped on function. You will see what there are connection of chapters in mathematics. Yes, it is a truth. So that's why important it is important that we should start from starting, then gradually we should keep moving. So here I don't want you to give too much motivation. Here we have a relation and function. before we start learning Before we start learning relations and function class, let's us go through some basics of a sets. Some basics. Uh, as we learn, a set is a collection of object. Yes, in a set we put objects or elements. You have also learned about the empty set. Yes, a set which does not have any element is called what? Empty set. Universal set. Universal set is a set which contains all sets, and it can put other elements, and all the other types in sets. Yes, types of sets we saw what? Infinity, uh, what singleton, empty set, subset, superset, and what else? Uh, Singleton. Yes, all this we saw. Let us learn here the Cartesian product of sets. Yes, okay. We have seen this, but again, as a revision, we will look at this Cartesian product of a set. As this chapter will be used further, as this chapter will be used to further to explain a relation and function for class 11 solution. Here, this is a from set chapter. It is given here because of there is a link of this with a relation, that's why, and there is a link of relation with a function. That is how it works. So here, until unless we have this basic this Cartesian product of sets, then we will not be able to understand what is a relation. That's why it is given here. Now, Cartesian product of sets. In our language, we can say that a set which has what order pair elements. For example, 2 comma 5. This is one element. Then 6 comma 7, 13 comma 2, like that. And we put like that when we have two sets. When we have two sets, then we take what? First of all, we take x, then we take y. Practically, let's see. Suppose there are two non-empty sets, which means a set has some elements. This is the meaning of a non-empty set. A and B. Okay. So the Cartesian product of A and B is the set of all ordered pairs of elements from A and B. Remember, you should not have empty sets. You should have non-empty set. Then you will get ordered pair of elements from those sets. Here we have this. This is called Cartesian product of sets. We just multiple A sets by B sets. That is what we do, and this is what is a Cartesian product of a set. Now next we have A comma B, and here it is telling you A comma B. We have two sets. A will belong to A, this, and B belong to this. So I think AB should be elements. Let A here we have in first set we have this much elements A1, A2, A3, and in this we have two elements. So this is not a Cartesian product. We have to convert this into Cartesian product. So how will we do? Just multiple this A by this. So here this is x, so this would be y. This is x, this would be y. So here we will write how a1 into b1, a1 comma b1, a2 comma b2. That's it. Ahead we have what? A3. So here we don't have anything. That's why till here our will be what? Cartesian product of this set. Then the Cartesian product of A and B will be what? This A1 B1, yeah, A2 B1, A3 B1. Oh, this is Cartesian. A1 B1, A2 B1, A3 B1, like that. Then we have A1 B2, A2 B2, A3 B2, A4 B2. Here we have example. Let's us x, this we have. So this is what? This is a Cartesian product of these two sets. Let's us we have this A, B, C, and then 1, 2, 3. These are elements. Then what would be Cartesian product of set? Cartesian product of this set. Just x multiple y, and we know A multiple 1, B multiple 1, C multiple C comma 1. then a comma 2 b comma 2 c comma 2, then a comma 3 b comma 3 c comma 3. That is what will be Cartesian product of these sets. So here a comma 1 b comma 2 a comma 3 b comma 1 b comma 2 b comma 3 c comma 1 c comma 2 c comma 3. That is how we convert any two sets into Cartesian product of sets. As we already know that these are coordinates, and Cartesian product we are understanding. So of course coordinates, there are coordinates. This set has 9 order pair, and instead of, rather than counting this directly, you can tell that yes, we have 9 order pair. How? Just multiple these elements, number of these elements by number of these elements. So we have 3 and here 3. 3 3 is a 9. So yes, we have 9 elements, 9 order pairs, 9 order pairs. Directly by multiplying you can say we have this much order pair. We can also represent it as in tabular form. Two order pair x and y are equal if and only if the corresponding first elements and second elements are equal. Now this was about the Cartesian product of sets. Now we are able to move on the discussion of a relation. Here definition, let's see what is the definition of a relation. A relation R is the subset. This is what subset. Subset is what? Just a piece of a set. A subset is a piece of a set of another set. Okay. A relation R is the subset of the Cartesian product x multiple y, where x and y are two non-empty elements. Yes, now okay. It is derived by look, a relation is the subset of the Cartesian product. This it is also set, but it is a subset. A relation is also set, but it is a subset of a Cartesian product where x and y are two non-empty elements. It is derived by starting the relationship between the first elements and second elements of the ordered pair of x and y. The set of primary elements of the ordered pair is called domain of R, and the set of all second and here this primary. What is the meaning of this primary element? I will tell you, don't worry. Second elements of the ordered pair is called a range of R. What is the meaning of this? Here I can directly tell you here. So here this A, B, C, C, all these are X, and this will be what? Domain. And here this Y, 1, 2, 3, 1, 2, 3, all these are what? All these are range of the relation. Till here, are you clear? What is a domain? How to identify domain? How to identify range? Just look at here. This side x. As you know, this is x, this is y. This is considered as x, and this is considered as y. So all this x will be what? Domain, and all this y will be range. Till here we understood about this. Now for two sets x is equal to a, b, c. We have two sets, this one and second is this a, b, c, and here we have apple, ball, cat. The Cartesian product have 9 ordered pairs of these two sets. How to say proof? With proof, just multiple number of these elements by these elements. So we have 3 elements here, and in this 3 elements, so 3 multiple 3 would give us 9 elements, which can be written as x multiple. So we can write it as a Cartesian product of these sets by like that. a comma. First we will take x, then we will take so here first we will take this, then this. A comma apple, a comma ball, a comma ball, a comma cat, and b, like that. You know how to do. With this we can obtain a subset of x and y. When you will obtain subset of x and y, then you will have relation. Let's assume. Remember, relation is a subset, and this is not subset. It is a completely set. It is a Cartesian product. With this we can obtain a subset of x and y by introducing a relation. Okay, let's see how to uh, bring a subset of from Cartesian product of a set between the elements of x and y. Okay, r a b. Okay, a b. A is the first letter of the word. A is the first letter of the word. This is in set builder form, and x belongs to a belongs to x, b belongs to y. Therefore the relation between x and y can be represented as r is equal to a comma apple, b comma ball, c comma cat. Here what are you observing? Therefore the relation between x and y can be represented as a comma b, b comma ball, c comma cat. What is happening here? We only will take what this a comma b, again common thing we will not take this. Again a we will not take, then again a, no, this a comma apple, then b comma ball, then c comma cat. Here we have, this is the relation. We cannot say that this would be relation. This is the Cartesian product of a set, and this is the relation which is a subset. It is a subset of this Cartesian product of the sets. Remember. Now another example we have, x is what a comma b and y is a c comma d. Find the number of relation from x to y. From x to y, find the relation. Here we have x. Okay, find the number of relations from x to y. Number of relations. X Cartesian product would be what? A comma c, a comma d, b comma c, b comma d. That's it. So can we say number of order pair of this sets would be what? 2 multiple 2, 4. 4 of course. So number of the relation, it is the same. So 4. Number of the subsets, we have how much? Number of the subsets, we have 2 to the 4, 4 to the 8, 2 to the 4, 4 to the 8, 8 to the 16. Therefore, the number of relations from x to y is to 2 raised to power 4. 2 to 4, 4 to 8, 8 to. It is saying, it is also taking what? C comma a, b d comma a. Number of subsets, this much. Let's see what is a function. A relation. There is a connection of a relation with this function. A relation if is a relation f is said to be a function. We can convert a relation into function. Let's see. If every element of non-empty set X, if every element of a set X has only one image or range to a non-empty set Y, only one image or range to a non-empty, or if f is the function from x to y and x comma y belongs to f, and then fx would be y, fx would be y. Here if we put x is what 2, then where y is the image of x, this is the image, we can say this is the range of this domain. Under function f and x is the pre-image of y. Under f it is denoted as x arrow then y. N be the set of natural numbers and the relation R be defined as R is equal to a comma b and b is equal to r a square. AB belongs to n set whether R is a relation function or not. Solution from the relation R is equal to a comma b, b is equal to a square. We can see for every value of a natural number there is only one image. For example, a is equal to 1, b is equal to 1. If a is equal to 2, then b is equal to 4, so on. Therefore, R is a relation function. Here. R is a relation function here. Learn more topics with let's see what is it. Difference between this. Definition is what? Definition of relation. A relation is a relationship between sets of values, or it is a subset of a Cartesian product. Yes, we know. Denotation, a relation is denoted by R and a function is denoted by f, a small f or a big f. We have this here. Definition of this would be a function is a relation. A function is a relation with only one output of each input. Whatever we give input will be output after giving input. This is what is a function. Okay. R here we have what? This is a subset of a Cartesian product. 2, x, 9, y, 2, z. It is not a function as 2 is input. As 2 is input for both the x and y. That's why. Here we have 2 times the domain. This 2, this 2. That's why it is not a function. Here 2, x, 9, y. Here range can be same, but domain should not be shared. It can be relation, but it is not a function. Relation can be function, but function sometimes cannot be relation. Function, all function would be relation, but all relation sometimes cannot be function. Every relation is not a function, every function is a relation. Check out more difference between articles. Okay, codomain. Fractional. Codomain is what? What is a codomain? Codomain is just a range, and we take all ranges. Nothing we ignore. All ranges you are taking. It means all those ranges range are what? Codomain. That's it. It is referred to A as a range of function along with a few additional values. It is defined as the subset of the codomain. It restricts the output of a function. It is a totally okay. A is equal to this much. Here what is happening? If A is this much and this is input. Here A is this much, this is input, and now we are saying if function A, this is 2x, 2a, this is what we are saying. If function A is equal to 2a, okay, 2a. So here we have this. We will put this input in this, then we will get this output. 2 multiple 1, 2. A is equal to 2. Just we will put this input in this. We will get this much output. That is how function works. Hence, if the input is given 1, then the output will be 2. Output, this is it. This is input and this is output. Clear? So 1 is the domain. Here this is a 1 domain. It is not a range. So 2 is the range for that domain. This output would be domain. No, domain, range for this domain. But the collection of output 2, 4, 6 are the codomains of the function. Yes, total, all these totals will be range as well as all this would be codomain. This is what is a defined measure difference. From this you are crystal clear. How does the function work? Just we take input and we apply that input, then we are given a output when we apply input there. That is what is a function. Now next let's see relation and function, important question. Not relation, functions and algebra. Let's see what is it. What are functions? We know this. Here you can see 2 is mapping 4, 3 is mapping 9, 5 is mapping 25, 9 is mapping 81. Here what would be order pair? We will have what? 2, 4, 3, 9, 5, 25, 9, 81. This is what is a relation. This is what is a relation, 1 to 1. Operations on the real functions. Now that we understand what functions are, let us discuss how we perform mathematically operations on real functions, such as the addition of 2 or more functions, subtraction of two function, multiplying a real function by a real number, adding two real functions. For adding two real functions, let us define the functions f and g such that if x relation and g x relation are two real functions such that x is a subset, this is a subset, and of R, okay, then f plus g such that x function R can be defined as f plus g into x, then is equal to f function x plus g function x for all x belongs to x. Subtracting two fractions, just like that. Subtract. Multiplying, just multiply. Quotient of two function, f upon g into x. Then f upon x, fx upon gx. Given that Just we add f plus gx, fx plus gx. This is what is adding two real functions. Relation function worksheet. What is relation? Relation can be described as a set of order pair. Let's look at this. We have 1, 0, 25, 50. Monday, Sunday, 2 Saturday. These are order pair of sets, where this denotes this set simply as this, and this element, comma element. This is what it is, a coordinate. A relation is a correspondence among two sets. Meaning of this word, this is both are corresponding. Now as the domain and range. This side would be domain and this side would be range, such that there are one or more elements assigned to every element or member of the domain. Example, we have 2, 4, 2, 3, 3, 7, 5, 2 is a relation of this domain 2, 3, 5. Here we got from here this domain we got from here 2, 3, 5. Same thing we will not take again. Same thing. This 2 is coming again. Range we have 2, 3, 2, 3, 4, 7. This is what range, and we arrange this in ascending order. We manage this in ascending order. What is a function? What is a function? A relation f from set x to set y is said to be a function. From set x to set y is said to be a function if every element of set x has only one image in set y. Only one image, not again. Every element of set x has only one image in set y. In set only should be one thing again, not should not come again same thing, same element. This is what is the meaning of this sentence. The function is systematically represented as a f. Okay, it means that the f is a function from set x to set y. X is called the domain of a function. F and y is called the codomain of the function f. Codomain. Worksheet on relation and function. Solve the problems. Determine domain and range of the given function. So of course domain would be what, 17, 10, 8, 6. So we will arrange this 6, 8, 10, 17. This is what these are domains. Now what about range? So -9, -5, 3, 4, -14. So of course first would be -14, -9, -5, 3, 4. These are range. In this we have 5, 3, 7, 16, 6. So 3, 5, 6, 7, 13. These are domains. Now what about the range? Range we have 5, 8, 4, 2. So 2, 4, 8. These are range. Find the dominant range value from the given tabular form. These are what? These are domains. These are ranges. These are ranges. Find the domain and the range for the given relation. Suppose 16 minus 16. This is the for you. Minus 16, comma 7. minus 7 comma minus minus 6 comma minus 7 2 comma minus 7 2 comma 11 8 comma 5 10 comma 7. Okay, we were here. Relation and functions. Relation and its a type. Wow. This should be useful for us. Now let's explore this relation and its a type. Empathy relation, universal relation, identity relation, inverse relation, reflexive relation, symmetric relation. All this we will explore here. We know what is the definition of relation. Now let's explore types of a relation. First we have empathy relation. Let's see where is empathy. Here we have empathy relation. Empathy relation. An empathy relation or valid relation is one in which there is no relation between any element of, of a set. For example, if a set A has this much element 1 2 3, then one of the void relation can be R is equal to x comma y, where x minus y is equal to 8 for every relation. We don't have another set. We don't have another set. Universal relation, we will take all the ordered pair. A universal or full relation is a type of a relation in which every element of a set is related to each other. Consider set A is equal to A comma B comma C. Now one of the universal relation would be x comma y, where x minus is what is equal to 0 or less than greater than 0 for universal relation. R is equal to A comma A. Identity relation. In identity relation, every element of a set A is related to itself only. For example, in a set A is equal to A comma B comma C, the identity relation would be A comma A, B comma B, C comma C, or A comma A. This is what is an identity relation. A belongs to A. Inverse relation, just opposite of this. A comma B, C comma D. Opposite it would be what? B comma A, D comma C. Just we convert x, y. Reflexive relation, we have this 1 comma 1, 2 comma 2, 1 comma 2, 2 comma 1. The relation is given by like that. We have this set. Set A has 1 2. And now an example of relation will be r this much 1 comma 2, 1 comma 2, 2 comma 2, 1 comma 2, 2 comma 1. Where is another set? Systematic relation. In a systematic relation, if A is equal to B, is it true? Then B is equal to is also true. In other words, A relation R is a systematic only if B comma A belongs to R is true when A comma B belongs to R. An example of a systematic relation will be R is equal to 1 comma 2, 2 comma 1 for a set A 1 comma 2, 2 comma 1. So for a systematic relation, this transitive relation. For transitive relation, we have if x comma y belongs to R, then y comma z belongs to R, then x comma z. Equivalence relation. If a relation is a reflexive, systematic and transitive at the same time, it is known as the equivalence relation. Even I didn't understand. Here we have this. In short, A multiple A. Pi is a subset of this, and we have two subsets. It's a self in opposite of two sets, opposite of order pair. A set of order pair is defined as a relation. This relation of this is with relation of 2 is with n, relation of f is with a, relation of 7 is with n. These are relations. So 1, 2, 5, 7 are domains. A, C, N are range. A relation of this is with this, relation of this is with this, relation of this is with this, relation of this is with this. Sets and relations. Okay, this is clear. Now let's explore trigonometric functions. Trigonometric functions. Trigonometric function. We are crystal clear about function. So now we have a trigonometric function chapter. If you came from 10th standard, so you will be familiar. Of course, you will be familiar what is a trigonometry. What is a trigonometry? We take a triangle and then we measure sides of a triangle with angle relations of angles relation what is the measurement all about all we under all sides we measure all sides we our focus will be on discussion of angle in this. Do you know what is the ratio in this? Ratio of sine A, ratio of cos, tan, sec, cosec, all these are ratios of trigonometric. All the concepts in the class trigonometric are covered. Okay, now directly we want to start. The topics and subtopics covered in trigonometric function class 11 include. First of all, we will start with the introduction, then we will see angle, then we will see trigonometric function, then we will see trigonometric functions of a sum and the difference of two angles. Introduction to trigonometry. The word trigonometry is derived from the Greek word trigono and metro. Trigono, which means three angles, three sides. Metro, which means measurement, which means measuring the sides of a triangle. Trigonometry is a branch of mathematics which helps to study the relationship between the angles and the side length of the triangle. Right triangle. In the early classes, we have learned the different trigonometric ratios of the right triangle. It is taught in 10th class, and that's why I said you that you would be familiar if you came from the 10th standard to understand it. Then you know what I am saying from here to tell here. In trigonometric functions class 11 in this class we are going to study the generalized concepts of a trigonometric function and their properties. Okay, what is angle? Just rotation. We see what is the amount of rotation is angle. Whatever is the amount of rotation would be angle. We take two line segments and then uh, first would be initial and second would be terminate side. When we rotate like that, so this much rotation is the angle. An angle is a measure which gives the relation of a ray about its initial position. In other words, the measurement of an angle is amount of rotation performed to obtain the terminal side from the initial side. We take two sides. First would be initial side, second would be terminal side. Work of terminal side is to terminate. Then we will be able to observe that yes, this much rotation happened. The angle can be measured into two different ways, such as degree and radian. These are two waves. Through these two waves, we can measure the angle. Let's see what is the degree. If rotation of the ray from the initial side to the terminal side is how much? This much. We rotated 1 degree from the 360 degree. 1 degree, only 1 degree we rotated. This is what is the meaning of this, of the revolution. Then the angle is considered. Then angle is considered to have a measure of 1 degree. Meaning of this is what? We rotated only 1 degree, just 1 degree. Radians. What is the meaning of radians? The angle subtended at the center by an arc length of 1 unit is a unit circle is considered to have a measure of 1 radian. Just 1 degree is 1 radian. Relation between degree and radian, as we know that this circle subtends at the center of an angle whose radian measures 2 pi. So upper would be half would be 1 pi and full would be 2 pi. This is complete radian. So two multiple value of a pi in the context of a circle would be what 100. In the context of radian I am telling you. So pi 1 pi would be equal to what 180. So we have 2 pi. So 2 multiple 180 would be 360. This is a complete circle. 360 is a complete circle. And its a degree measures its a degree measures a 360 degree. So 360 degree is equal to 2 pi. This is what we are saying. Hence we give to 2 pi is equal to 360 degree. So 2 pi is a radian and 360 is a degree. Or pi radian is equal to, we are not saying what is the value of a pi, we are saying what is the value of a pi radian. So value of a pi radian would be 180 degree, remember. And now a complete circle would give us a 2 pi radian. Okay, therefore 1 radian is what 1 radian would be 100 upon pi. So we know what is the value of a pi radian. So of course 100 upon 100, so it will give us 1. Hence 1 radian is what 15 15 15 57 degree, and this much approximately this much. And 1 degree can be written as 1 radian is equal to 1 degree is equal to pi upon 180. Radian is what radian is this much. Trigonometric functions, the trigonometric functions are also called the angle. Trigonometric functions are also called the angle function, which relate the angles and the ratio of the sides of a right angle triangle. Considering the unit circle, we take unit circle which radius should be 1 centimeter, 1 meter or 1 centimeter. The 6 important trigonometric functions are given as follows. We know what is sine, tan, cos, cosec, sec. All these are 6 trigonometric functions. If n is an integer, then sin x would be 0. Sin x would be 0. S is equal to n pi. The other trigonometric function in terms of the sine and cosine functions are given as tan is equal to, we know tan theta is equal to sine upon cos, then cosec x is equal to 1 upon sine, sec x is equal to 1 upon cos, cot x is equal to cosec upon sine x. Okay, sum and difference of two angles. Sum of the important expression for the trigonometric function of the sum and the difference of the two angles and related expression we have to. So remember, this would be as it, this would be not, this is just, here we have inverse operation, because these are formulas. It can be remembered while doing questions. How to convert 6 radians into degree measures? So first of all, we have 6 degree. We now 1 pi is equal to what? 1 pi is equal to, we have 6 radian and we want to convert it into radian. So of course 2 pi is equal to 360 degree. So 2 pi we have this much 6 radian. So it should be pi radian is what 180. So 1 pi this much. So 6 pi would be this much multiple 6. So to give us this much approximately. These are questions for you. Trigonometric functions. Now let's see what does AI say when I will promote, when I will give a, and I will ask something. So I have being. I want to see what will AI say about a trigonometric function. Uh, make a note. Make a notes of trigonometric functions of class 11th for understanding. For understanding. So it is saying first angles and their measurement. We are crystal clear about it. Then we have trigonometric functions. We know this. Okay. Then we have formulas. We already know. It is in pi radian. Coordinate 1 all ratios positive. Coordinate 2 sine and. Okay, this was something else. Then this formula. Then graphs of trigonometric. General solution. Applications. Wow, it gave us something different from the our discussion. Now let's say PPT of this. PPT of this. PPT of trigonometric class 11th. PPT, yes, PPT. Google Slides. It's working. Trigonometry. I am looking what's the difference among this. Whatever discussed will it be different from this PPT? If yes, then we will explore it as well. Uh, Angle trigonometric function. This is what our table content. First we will see what is angle trigonometric function for some, okay, functions for multiple of angles, C plus D formula, trigonometric. The word trigonometry is derived, okay, we are familiar with this. We are familiar with this. We have this right angle triangle. So this is what perpendicular. It is considered as an 90 degree. This is adjacent, and this is opposite of this. So and this is a fixed hypotenuse. It can be opposite and it can be adjacent according to theta. It is considered. Okay. This subject was originally developed to solve geometric. This subject was originally developed to solve geometric problems involving. It is a study because we can solve problems. That's why related to geometric. Angle, units of angle, relation between degree and angle. Okay, we have this here. This is first it we are going to consider it as an initial side. Now next, this would be terminal. This would be terminal side. Remember. And to what is the amount? What is the amount of rotation between these two sides? This much. This much would be angle. This much would be angle. So here this is angle. From initial side till the terminal side would be angle. This is an initial side, and this is vertex. This would be vertex, and this arrow is representing it is what infinity. This arrow is representing about infinity. It will keep going on. It will keep going, but it started from here. This is what vertex. It is not ending. This is ending. This is not infinity. It started from here and it is going. This side would be known as terminal side. Next we have vertex. Next we have what? Vertex. Here same. What's the difference between this? Difference is what? This is a downward. It is a, you can see a sign of this arrow. What is happening? This is a opposite. This was in this side and this is the opposite. This is what? This would be known as clockwise and this would be known as anti-clock. You see how the hand of a clock works. Same here. This is working like hand of a clock, and this is just opposite of clock. So here, if rotation is anti-clock, this anti-clock angle would be positive. This would be positive. This is what anti-clock. If rotation is a clockwise, this would be negative, because it is rotating negative. That's all. Okay, clear. Units. One revolution means complete 360 degree one times. So one complete a circle would be one revolution. So here we have initial side. This initial side and turn side would be same here, and this is what is a one complete revolution. It rotated 360 degree. Now degree. What is a degree? Degree, minute, second, radius. Degree, let's see. So one revolution is equal to 360 degree. One revolution. Yes, we know. One complete would be 360 degree. 1 upon 360 of the revolution is 1 degree. 1 degree. Yeah. Or 1 radian. 1 degree is equal to 16 minutes. 16 minutes. Example, convert the following into degree measures. Convert the following into degree measures. So we have this. Convert the following into degree measures. So 50, 45, 1 radian. So answer would be 1 degree is equal to 60 minutes. So 1 minute would be 1 upon 60. 1 degree would be 1 upon 60. Second, I think it should be 60. It should be 16 second. Then this would be our answer. Now next we have radian. What is a radian? This is just, it is, we can also define a rotation as a radian or as a degree. If a circle of a radius r, an arc of length l, subtends an angle 0 radian at the center, then we have this much would be what? This. It is a subtending this arc. We have here arc, this arc by 2 radius. Then this will give us a radian. Theta is equal to 1 and 1 is equal to r theta. Example, we have find the radius of the circle in which a center angle of 2 pi upon 3 intercepts an arc length 37.4 centimeter. I think it should be radius. So solution would be this is much length and this is a angle. We have this radius. So radius is what? 1 upon theta. So theta is this much. We will substitute this in this. We will get r. This much we have r. And length. What is the length? Length, an arc, this length of arc. The time hand of a watch is a 3 centimeter long. 3 centimeter long. This, so 3 centimeters. So it is what? Radius. How far does its tape move in 40 minutes? Use this value of by this much. In that case, pause the video. Time duration 3 minutes. 1 revolution is equal to 360 degree. 360 degree. 1 revolution is equal to 360 degree. Okay, we know. So 60 minute would be 1 revolution. Yes, 4 minute hand. For 40 minute would be what? 2 upon 3 of a revolution. Okay, then we will put value of 1 revolution would be 360 degree. This much came radian. Concept test. Ready for challenge? We have this much question for you. Convert degree into radian. Just degree. Then we have this radian. Pi upon 180 degree. then pi would be as it, then we will simplify it 60 upon 30, 180. Convert this radian into degree. So we now 60 and then multiple 300. 60 pi is equal to 300. Pi radian is equal to 180. Okay, 60 radian is equal to what? 180 upon 5 multiplied 60. We have this much questions for you. Next, trigonometric ratio has been now signed according to this angle. We will take what? We will get this upon this, BC upon AB. Cosine same opposite of this, AB upon AC, AB upon AC. Base upon this, base upon hypotenuse. We are familiar with these are questions. Let's explore this. In this, what is happening? We have this circle with one radius on a Cartesian plane. Remember, this is what first coordinate. This is a quadrant. This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. Okay. Here what is happening? Here in this first all trigonometric ratio would be positive, but when it comes to here, then something else will happen. Here we have what? This cos and this is sine. A upon 1 is equal to A. Okay. We have this much questions. What the hell? This PPT is this PPT is useful. This PPT would be useful. We have this much. Okay. I will explore all this. Let me share it. What else can be studied from this? Let's explore. We have this much. 11 videos, slides, 11th. What about 12th? Study resources. videos work. Slides, we want slides. Physics, maths, so I think maths, we have all chapter. Matrix. It is a very nice website. It is a very best website for mathematics because it gives in details all about all concepts, all topics with the question practice. Wow, what is the explanation? You can see. This is too much better than website. Now I realized. What if you take uh, class 11, class 11, yeah, math. Then set. Let's explore what is a set. Wow, it is also in a very nice set. Now let's select another subject. Another subject is